Hello friends, welcome back. Hearty welcome to you. Let's look at this problem related to theory of equations. We have been given that if one root is square of the other root of the equation x square plus bx plus q equal to 0, then what's the relation between p and q? So once we have been given a quadratic equation, that is x square plus px plus q equal to 0. This is the equation we have been given, and we were told that one root is square of the other. So let us take one root is alpha, then the other root will be alpha square. Now we know the relation between the coefficients and zeros of a quadratic equation. So we can go back and say now alpha first root plus the second root equal to minus of b by a. This equation is in the form of ax square plus bx plus c equal to 0, and we know that alpha plus beta is equal to minus of b by a. Can I write down alpha plus alpha square is minus p, and also product of the zeros alpha into alpha square, that is equal to alpha cube, equal to c by a, that is equal to q. So what's the relationship we are giving here? We are saying that alpha plus beta equal to minus of b by a, and alpha beta equal to c by a. By leveraging that properties, we found that alpha plus alpha square is minus p and alpha cube equal to q. Let's come down and write them now. So we know that alpha plus alpha square is equal to minus p, comma alpha cube equal to q. Now we have to establish a relationship between p and q, and we have to give what is the relation between p and q. Now you see that alpha plus alpha square, the highest power is 2 here. Alpha cube, the highest power is 3 here. Now suppose I want to get a relation between p and q, then I should go to that power which is multiple of 2 and 3. That means I have to make both of them as multiples of 2 and 3. LCM is 6. So why can't we cube it on both sides, so that when I cube I get alpha cube alpha power 6, which I can use certainly q value. So let me do that. I'll say cubing on both sides. This first equation, I have alpha plus alpha square whole cube equal to minus p into whole cube. Let's go to the next step. We know this is a plus b whole cube, that's what we are doing now. So a cube alpha cube plus b cube alpha power 6 plus 3 into a into b, that is 3 alpha cube, into a plus b, that is alpha plus alpha square, is equal to minus p cube. What's the formula we have used? A cube plus b cube plus 3ab into a plus b, for the formula a plus b whole cube. A plus b whole cube is given by a cube plus b cube plus 3ab into a plus b. Now let's simplify this. We will get alpha cube plus alpha power 6 plus, we did that already. We can directly go ahead and substitute them now. We know what is alpha cube value. Alpha cube is nothing but equal to q. We know that alpha cube is equal to q. So we can go back and substitute q here, plus q square plus 3 into q into alpha plus alpha square is minus p, is equal to minus p cube. So let's get everything to one side. It will become p cube plus q minus 3qp plus q square is equal to 0. I can leave it like that, or I can take q common and say p cube plus q into 1 minus 3p plus q square is equal to 0. So that's a relation between p and q, that is p cube plus q into 1 minus 3p plus q square equal to 0. So let's just go through this again, summarize. One root is square of the other root. We have been given equation is x square plus px plus q. This is based on the condition geometric relation between the zeros and quotients of a quadratic polynomial. We know alpha plus beta is minus b by a and alpha beta equal to c by a. Substituting that values, whatever we know alpha and alpha square are the roots of the equation. Let them be, because we know one is square of the other. We get alpha plus alpha square equal to minus p comma alpha cube equal to q. Now to establish a relationship between p and q, we need to cube on both sides so that I can leverage the value of q. Alpha and alpha square, from if I just do like that, it becomes very difficult to get the relation between them. So to get the relation, we have to cube the first equation, so that we will get alpha cube plus alpha power 6, where I can go back to q and I can use that value. So that's one problem which I thought of sharing with you. We'll be doing more problems as part of theory equations. These are previous year IIT question. Thanks for your time and support. Bye for now.